we can define two liquid domains. Liquid on the surface of a particle, bound liquid, and liquid far away from the particle surface, bulk liquid. When a liquid molecule adsorbs to a particle surface, in other words, wets the surface, its rotational and translational motion is restricted, and so the bound liquid molecules, shown here in darker blue, relax much more quickly, on the order of 0.5 to 2 milliseconds, much more quickly than the free liquid molecules that are far away from the particle, shown here in light blue. They relax on the order of 2 to 3 seconds. In reality, of course, it is a dynamic equilibrium where the liquid molecules rapidly switch between the surface and bulk domains. This is called fast exchange. And this is faster than the time scale of a single NMR experiment. That is why we only observe a single relaxation time. So any changes in the extent and nature of the surface or the rate of exchange can be measured with NMR. A suspension of particles in a liquid with a large wetted surface area, for example, a nanoparticulate pigment, will have a smaller relaxation time than a suspension with a small wetted surface area, for example, micron-sized active pharmaceutical materials, because in the former there is more liquid molecules fluid associated with the particle surface. So now let's look at a practical situation. There are three separate relaxation phenomena occurring simultaneously, as shown in the graph on the left. The first is that for a bulk liquid, and ideally we need to measure this independently. The next is that for the solid surface. Here the relaxation time is so fast that we can ignore it using our low field Acorn Area instrument. Third, there is the relaxation time of a suspension. Since the solid surface relaxation rate is so fast, it does not take much surface associated liquid to produce a significant shift in the relaxation rate of a suspension compared with that for the bulk liquid. The upper graph on the right shows how the relaxation time decreases as the particle concentration and hence total wetted surface area in a suspension increases. The example given here is for an aqueous dispersion of a 100 nanometer titanium dioxide. The biggest change, shorter relaxation time, occurs for high concentration suspensions. For repeatable measurements, it is important to know the concentration fairly precisely, especially the more dilute a suspension. Although what is measured is a relaxation time, we can define a new term, the relaxation rate, as the reciprocal of the relaxation time. This change in parameter, Alex, I'm going to start that sentence again. Although what is measured is a relaxation time, we can define a new term, the relaxation rate, as the reciprocal of the relaxation time. This change in parameter linearizes the data, lower graph on the right, and so provides a much more convenient means to express the data. Finally, NMR relaxation is an exceptionally informative technique. As I've mentioned earlier, it can be used to probe the extent, wetted surface area, and nature, surface chemistry, of a particle surface, and look at the effects of morphology and porosity. Each of these subjects will be discussed in more detail in future short webinars. NMR relaxation is also very useful in optimizing formulation development. Any species that can displace the bound liquid of a wetted surface, such as a dispersant or a surfactant or a polymer, will change the relaxation rate. Hence, we can use NMR relaxation to study adsorption and desorption processes, comparing and contrasting, for example, the efficiency of wetting agents, dispersants and stabilizers, as well as sedimentation rates. It is particularly useful to study aggregation phenomena such as flocculation and coagulation. Because NMR measurements can be made at any concentration, the technique is very convenient to monitor milling and grinding almost in real time. Again, Each of these applications will be covered in future webinars. At a practical level, NMR relaxation measurements will find use from blue sky exploratory research and development through quality control, quality assurance to process monitoring in almost any industry.